Hello and good evening to everyone. Now we are going to present our network design problem-based task presentation. Before we start our presentation, we would like to introduce ourselves. Myself, YEOSINI, daughter of Rajindran. My matric number is 25DDT19F1053.
My name is VANISRI EGAMBARAM. My metric number is 25DDT19F1052.
My name is Thirasini Karunanithi. My metric number is 25DDT19F1062.
This is our problem-based task topology design, and now we are going to see the objectives of this problem-based task. Part 1 is interpret the result of EIGRP routing, and part 2 is discuss and share opinion about summarization in EIGRP. The last objective, which is part 3, discuss and share opinion about the wasted IP addresses in the design. Background or scenario given the IP addresses included in 192.168.8.0/22. Use this range of IP addresses to subnet and provide the IP addressing for the network. The network has the following addressing requirement. The router 2, 3, and 4 LAN will require 122 host IP addresses. The one link between each of the routers will require an IP addresses for each end of the link. Configure all the devices as per given in the topology. By end of completion, make sure basic connectivity tests and also end-to-end connectivity tests are successful. Part 1. Interpret the result of EIGRP routing based on output student get from assessment problem-based tasks. Now we are going to see output from router 1. When you want to see output from router 1, the first comment is show IP route. Here you can see the EIGRP route, the 192.168.8.0/24 and 192.168.9.0/24 and 192.168.10.0/24. The second one is show IP protocol. In show IP protocol, you can see here routing protocol is EIGRP10, and the second one is automatic network summarization. And here also you can see the 192.168.8.0/24 is summarizing with the metric 2169856, and the metric number and also you can see the IP address for 192.168.9.0 and .10.0 also summarizing with the metric 2169856. And also here you can see the routing for networks 192.168.8.0 and .9.0 and 10.0. And here also you can see routing information sources. The gateway IP address is 192.168.8.2 and 192.168.10.2 and 192.168.9.2. And the last one is show IP EIGRP neighbors. And here you can see the EIGRP neighbors in router 1. 192.168.8.2 is for router 2 and 192.168.10.2 is for router 4, and the last one is 192.168.9.2 is for router 3. And now we are going to see for the output from router 2. As the same is first one is show IP route. Here you can see we can get the two connected route and two EIGRP route. When you see EIGRP route for routing 192.168.9.0/24 and same as for .10.0/24. But in IP address subnet mask which is given is 25. But why here in router 2 the EIGRP route, here we can see the slash 25, 24, because this is route which is summarized by router 1 for router 2. You can see it clearly from router 1. Here you can see 192.168.10.0/24 is summarized for router 2, which is same as for 192.168.9.0/24. Now, the second one is you can see the show IP protocol in router 2. Here also you can see routing protocol is EIGRP10 and the automatic network summarization and routing for network is 192.168.8.0 and the gateway is 192.168.8.1. The last one is show IP EIGRP neighbors. The IP address is 192.168.8.1 for the ports S0/0/0. Now we are going to see output from router 3. In show IP route, you can see the 192.168.10.0 is summarized in router 1, advertised in router 3, and 192 and 168.8.0 also is summarized in router 1 and advertised in router 3. In router 3, the second comment is show IP protocol. Here also you can see routing protocol is EIGRP10. Automatic network summarization. Routing for network is 192.168.9.0 and the gateway is 192.168.9.1. Show IP EIGRP neighbors. IP address is 192.168.9.1, which is for router 1 and port is S0/0/1. Now we are going to see output from router 4. The command is show IP route. Here you can see the 2 EIGRP route, which is same with the router 2 and router 3, summarized in router 1 and advertised in router 4, which is 192.168.9.0/24 and 192.168.8.0/24. And also you can see the show IP protocol. Routing protocol is EIGRP10. Automatic network summarization. Routing for network is 192.168.10.0 and the gateway is 192.168.10.1. Show IP EIGRP neighbor is 192.168.10.1 and the interface port is S0/0/0. Now I will pass my turn to my friend VANISRI.
Thank you, Yoshini. Now we are going to do part 2. The question asks, discuss and share opinion about summarization in EIGRP. They got 2 questions in this part 2. The first question is, Yoshini, next slide. The first question is for part 2 is, they ask should or should not summarize enable in this design, and they also ask why. In this part 2 question 1, we have to do summarization should be enabled because this design, because it is a hierarchical network design. It also can reduce number of routers in routing table. Summarization can decrease the bandwidth, usage, and memory. Now we can see the question 2. Next slide. In question 2, they ask, would router summarization occur in a non-hierarchical design? And they also ask why. Route summarization would not occur in non-hierarchical design because a non-hierarchical design is small and unorganized than hierarchical design. Since it's smaller, its packet size will already smaller and it will use a small portion of the bandwidth for data transfer. That's all for part 2. Now I will pass my turn to my friend Thirasini. Thank you.
Thank you, Vanisri. Part 3, discuss and share opinion about the wasted IP address in the design. First, how many IP addresses in this design are wasted? Support your answer with a calculation. Next question is, what change should be made to this IP addressing scheme to be more efficient? Suggest the new subnet assignment and fill in the table below. Next, I pass to YEOSINI.
Thank you, Tirashini. The first question in part 3 is how many IP addresses in this design are wasted? Support your answer with a calculation. Okay, here when we see in the topology design hierarchical, do addressing scheme using subnet slash 24 for every connection and every WAN and LAN. Slash 25 give host IP address 128. Here we can see we have 126 and 128 usable IP address, which is in this part. Okay. From the design, the wasted IP addresses come from the WAN connection. This is because the WAN connection only need 4 IP addresses, which is 2 usable IP addresses and 1 subnet IP addresses and 1 broadcast IP. In the design, one connection uses the same subnet as the LAN, which is subnet slash 25, which give 120 IP addresses. When you see in the calculation, you will get it very simply. Here, 128 minus 4 equals to 124 wasted IP address for 1 only. Here we got the 3 1. If we multiply with 124 with 3, we get 372 wasted IP addresses total. Now I will pass my turn to my friend Tiyashini.
Part 3 second question is, what change should be made to this IP addressing scheme to be more efficient? Suggest the new subnet assignment and fill in the table below. First, in this topology, the given IP address is 192.168.8.0 and the host is 120 host. And the nearest subnet mask is 120 host is 128 subnet. 128 below is 64 subnet, but we didn't choose the 64 subnet because it's not enough for our topology. So we choose 120 subnet as the nearest subnet. Refer to the table. Subnet number 0, subnet 0, subnet IP 192.168.8.0. First usable IP address is 192.168.8.1. Last usable is 192.168.8.126. Broadcast address is 192.168.8.127. Subnet Number one, we use 192.168.8.128 as a subnet IP. First usable is 192.168.8.129. Last usable is 192.168.8.130. Broadcast address for I subnet number one is 192.168.8.131. Subnet number two, we use 192.168.9.0. First usable is 192.168.9.1. Last usable is 192.168.9.126. Broadcast address is 192.168.9.127. Subnet number 3, we use 192.168.9.128. First usable, we use 192.168.9.129. Last usable is 192.168.9.130. Broadcast address is 192.168.9.131. For subnet number 4, the IP address is 192.168.10.0. First usable is 192.168.10.1 and the last usable is 192.168.10.126. Broadcast address for subnet number 4 is 192.168.10.127. Subnet number 5 is 192.168.10.128. First usable for subnet number 5 is 192.168.8.129. Last usable is 192.168.10.130. And the broadcast for subnet number 5 is 192.168.10.131. Next slide, please. In this table, we change the last usable one nine last usable of subnet number one. We choose we take 192.168.8.130 change into 192.168.8.254, and we also change broadcast address 192.168.8.255 into 192.168.8.255.
That's all from us. Thank you.